Chemical bonding. Type of bonding: covalent, electrovalent, and coordinate. Covalent: bond formed by the transfer of electrons from metal to non-metal. Electrovalent: bond formed by sharing of electrons between two nonmetals where the shared pair of electrons are contributed by both atoms. Example: HCl. Coordinate: bond formed by sharing of electrons between two atoms where the shared pair of electrons are contributed by one atom and shared between two atoms. Example: NH3 positive. Features of electrovalent compound: compound of metals. Metals can combine only with non-metals. Metals are electron donors. They give out electrons and non-metal gain those electrons. They are made up of ions. Ions are held tightly by a strong force of attraction, that is electrostatic force of attraction. Features of covalent bond: compound of non-metals. No metals are present in covalent compound. Made up of molecules. Molecules are held by weak force of attraction, van der Waals force of attraction. Difference between electrovalent and covalent compound. Electrovalent compound exists in solid form, whereas covalent compound exists in liquid or in gaseous form. Electrovalent compounds have high melting point and boiling point. Covalent compound have low melting point and boiling point. Electrovalent compound are good conductor of electricity. Covalent compound are non-conductors. Electrovalent compound are soluble in water and insoluble in organic solvent, whereas covalent compound are insoluble in water and soluble in organic solvent. Why electrovalent compounds can conduct electricity? Because they are made up of ions. Why covalent compounds can not conduct electricity? Because they are made up of molecules, no ions are present to conduct electricity. Why electrovalent compounds are solid? Because they are made up of ions which are held by a strong electrostatic force of attraction. Why covalent compounds are liquid or gas? Because they are made up of molecules which are held by weak force of attraction. Why electrovalent compounds have high melting or boiling point? Because they are made up of ions which are held by strong electrostatic force of attraction, so no more energy is required to break the force of attraction and to separate the ions. Why covalent compounds have low melting or boiling point? Because they are made up of molecules which are held by weak force of attraction, so less energy is required to break the force of attraction and to separate the molecules. Electrovalent compound in solid state cannot conduct electricity because in solid state ions are held by strong force of attraction and they are not free to move. Types of covalent compound: polar covalent compound, non-polar covalent compound. Polar covalent compound. A polar covalent compound is formed by unequal sharing of electrons between two atoms due to difference between the electronegativity of two atoms. Example: water, hydrogen chloride, ammonia. Non-polar covalent compound. A non-polar covalent compound is formed by equal sharing of electron pairs between two atoms. Example: methane, carbon tetrachloride, and benzene. Differences between polar and non-polar covalent compound. Polar covalent compound. Compound with some sort of charge separation due to difference in the electronegativity of the combining atoms. Non-polar covalent compound. Covalent compounds with no charge separation. Polar covalent compounds are soluble in water, whereas non-polar covalent compounds are insoluble in water. Polar covalent compound conduct electricity in aqueous state. Example: HCl. Non-polar covalent compound do not conduct electricity. Example: NH3. Electrovalent compound dot cross diagram. 3 steps of electrovalent compound dot cross diagram. Step 1. Combining atoms with dots and cross to represent valence electrons and arrows to show transfer of electrons. Step 2. Cations and anions. Step 3. Formula with the charge of cation and anion. Sodium chloride Na11. Configuration of sodium is 281. Chlorine 17. Configuration of chlorine is 287. Sodium has 1 electron in its outermost shell, whereas chlorine has 7 electrons in its outermost shell. In order to complete the octet, chlorine requires 1 electron, which it borrows from sodium. So here sodium loses electron and chlorine gains electron. Sodium, after losing 1 electron, attains noble gas configuration, that is sodium 2,8, and chlorine, after gaining 1 electron, attains configuration as 288 and becomes stable. So charge on sodium becomes Na positive and charge on chlorine due to gaining of electron becomes Cl negative. Hence, we get the compound as Na plus Cl minus. Calcium chloride CaCl2 Ca20. Configuration of calcium is 2882. Chlorine 17. Configuration of chlorine is 287. Calcium has 2 electrons in its outermost shell, whereas 2 molecules of chlorine has 7 electrons each in its outermost shell. Now, in order to complete its octet, chlorine gains 1 electron each from the calcium atom. Now calcium, since it loses 2 electrons to 2 chlorine atom each, becomes Ca2 positive, and chlorine, after gaining electron, becomes Cl negative. Now the overall configuration of the compound becomes Ca2 plus Cl minus 2. Magnesium oxide MgO. Configuration of Mg12 is 282. Configuration of oxygen 8 is 26. Magnesium has 2 electrons in its outermost shell and oxygen has 6 electrons in its outermost shell. Magnesium loses 2 of its electrons to oxygen. Due to loss of 2 electrons, magnesium becomes Mg2 plus, and oxygen, due to gaining of electron, becomes oxygen 2 minus. The overall configuration of the compound becomes Mg2 plus and O2 minus. Covalent compound. Dot cross diagram. Atoms with valence electrons represented by dots or crosses. Sharing of electrons. Bond present in the molecule. Example: ammonia. Ammonia, nitrogen 7, 2, 5, hydrogen 1, 1. Nitrogen has 5 electrons in its outermost shell. 3 atoms of hydrogen shares 1 electron each, which leads to completion of octet of nitrogen, and the compound formed is NH3, where nitrogen has 1 lone pair of electron. Ammonia has 3 covalent bonds and a lone pair of electron. Water. O8, configuration is 2,6, hydrogen 1, configuration is 1, oxygen has 6 electrons in its outermost shell. 2 atoms of hydrogen shares its 1 electron, which leads to the formation of compound H2O. Oxygen has 2 lone pair of electrons in it. Water has 2 covalent bond and a 2 lone pair of electron. Covalent compound. Methane CH4, carbon tetrachloride CCl4, hydrogen chloride HCl, hydrogen sulfide H2S, hydrogen molecule H2, chlorine molecule Cl2. Oxygen. Oxygen molecule has a double covalent bond between 2 oxygen atoms. Nitrogen. Nitrogen molecule has a triple covalent bond between 2 nitrogen atoms. Coordinate bond. NH3 has completely filled orbitals and has 1 lone pair of electron. It donates its 1 lone pair of electron to H1+, which leads to the formation of compound NH31 positive. Water has its completely filled orbitals. Oxygen has two lone pair of electron on it and it donates one lone pair of electron to H1+, which leads to the formation of compound H3O1+. Ammonium chloride has all three types of bond, electrovalent, coordinate and covalent.